All right, thanks for joining in, guys. So we're at the range today and we've set up a couple of different rifles here. Specifically, I've got a 6.5 Grendel here in the AR platform, and we've got its big brother, the 6.5 Creedmoor, here on a MDT LSS chassis platform. Today we did a tall target test with the Sig Tango 4. If I can get that to focus, there we go. Sig Tango 4, that's the 6x24 by 50 millimeter model. And then we also did a tall target test here with the Burris XTR II 5 to 25 by 50 millimeter scopes, and that's in the 34 millimeter tube version. So I'm going to spare you the details of shooting today. It's about 10 degrees, it's kind of cold out. You can see I've done some chronograph action, and then I'll see if I can zoom in down here, sorry for the shake, our tall target test. And we'll go down and take a look at that. I've already shot the targets this morning. We'll go down and take a look at it. We're doing a tracking test essentially for both of these scopes to make sure that they're tracking properly vertically, that the scope is mounted properly in the bases with the scope level for both rifles, and then also to make sure that they're tracking vertically or horizontally as correctly as well. So we want to make sure that they're traveling the correct amount of travel per 30 clicks. So what we did is we fired at a single aim point down on the target down there. We adjusted up 30 MOA and then fired a 3-shot group as well. So again, we're taking a look at a 6.5 Grendel. We've got the Tango 6 by 6 Sauer, 6 to 4 by 24, and then the Burris XTR II on the 6.5 Creedmoor here. So let's go down and take a look at the targets. We'll evaluate the targets and we'll kind of go from there. Alright, now we're down here at the target. This is our tall target test. You'll notice that I have 3 vertical lines on the paper here. It's very important to make sure when doing this test that you use a 4-foot level to make sure that your lines are completely level. It's a great way to check your reticle also, to make sure that your reticle is level with the level on the scope. You guys watch my other video on how to level a reticle on your scope using the flashlight method. That was done here on both these scopes, and you can see that they're pretty close. The left target is going to be the 6.5 Creedmoor, and the right target is going to be the 6.5 Grendel. And you'll notice that we fired a 3-shot group right down here at this single point of impact. The group was off just a little bit, and that's okay. I don't know whether it was me or the gun or the temperature or what, but it's pretty close to the last shot was the one that was right in the center, and I did make one little adjustment. So we dialed up 30 MOA and we shot this group here, and it's the center of the group is obviously right on the line, so I'm happy with that. Not real happy with the group size, but it's not bad. We're just doing some testing today for the actual scope, not the gun itself. So pretty happy with that. We'll take this target back in the garage when it gets a little bit warmer out, or not warmer out, but where it's a little warmer, and we'll evaluate this target back in the garage, and I'll show you how to do those calculations. Here's the 6.5 Grendel. Everything's just a little bit on the left side of the line there, and again, that's okay as long as it correlates at the top. We dial up 30 MOA, and we got this group here, which is just obviously centered on the left side of the target as well. It's interesting that these groups open up as you climb up to the top of the target. I don't know why that is, but it is what it is. So there's the tall target test. For perspective, that piece of paper is just about 4 feet tall, so you'll need a good sized piece of wax paper. I use freezer wrapping paper for this test. So let's get back to the garage and into the shop, and we'll measure these out and we'll do the calculations, and we'll see how our scopes are tracking. Alright guys, thanks for joining us. This is our tall target test that we ran out at the range this morning, and we brought it back to the shop here where it's a little warmer. It was about 10 degrees out this morning when we were shooting, and I had to get to church, so I didn't have time to do the video out there. But we're back in the shop. It's a little warmer in here. You can see I've got the heater going. And we're going to go over the tall target test. What we've done here is I've done all the math, I've done all the equations already just to save you some time on the video. If you have any questions about that, post them in the comments and I'll help you afterwards. But what we've done here is you can see on the left-hand side we've got the Burris XTR, and on the right-hand side we've got the Sig Tango 4. This is a 5 to 25 by 50 millimeter. This is a 6 to 24 by 50 millimeter. 30 millimeter main tube, 34 millimeter main tube. And so what we've done is we shot this test this morning. Our actual yardage that we shot this morning, hopefully you can see this, is 101.9 yards. And so the calculations that we're going to do to check is first thing we're going to do is we're going to measure from the center of our aim point to the center of the group for each of these targets. I've already done that. And the from center to center, this group measured 32.250. And we're going to call that our actual point of impact. Okay? Same thing on this target. We measured from the center of the dot here to the center of the group. And our actual point of impact is 32 inches. So for the Sig Tango 4, 32 inches. For the Burris XTR, 32.250. And we got that as close as we could. You can see they're pretty darn close. This one's about 1/4 of an inch higher. And so then the next thing that we do is we're going to take our MOA, so 30, oops, dropped my pen here. We're going to take 30 MOA, we're going to multiply that by our range, so 30 times 101.9 in yardage, and then we're going to multiply that of a constant, and hopefully you guys can see it. The constant is 0.01047, and that's going to give us our expected point of impact. The expected point of impact for this yardage, using a 30 MOA dial, is 32.00679. All right? So the next thing we're going to do is we're going to take our expected point of impact, which is 32.00679, and we're going to divide that by our actual point of impact, 32.250, and we get 0.9924. All right? We do the same calculation over here for the Sig Tango 4. We take 32.00679. We divide that by our actual point of impact of 32 inches, and we get 1.000 and then a couple of digits after that. Really not important after you get 3 digits. And so that's going to give us these numbers are going to give us our correction factor. Okay, so we've got a correction factor of 0.9924 on the Burris and a correction factor of 1.000 on the Sig Tango 4. So essentially what that tells us is that both scopes are tracking properly. There's less than 1% error in both of these scopes. They're very close. The Burris is off just a little bit versus the Tango. The Tango is right on the money. So what does this tell us? Well, it tells us that when we dial 30 minutes of angle, our actual is pretty close to what our expected is. And so ultimately, if we were going to use the correction factor, for instance, the Burris is the best example because it's off, right? It's 0.9924, which is, again, less than 3% at 1,000 yards. So what we would do is let's say I range the target, it's 1,000 yards. And I know when I do my applied ballistics programming, either in my phone, in your rangefinder, your cue cards, whatever you've got, you look at your card, it says 1,000 yards, we're going to dial 30 MOA. Well, we've got a correction factor here because our scope doesn't dial exactly 30 MOA, right? So we take our actual, or what it's telling us, so 30 MOA, we would multiply that by 0.9924, and you would get 29.774 is what you're going to get. And so we know now, I know, that instead of dialing 30 MOA to hit that target at 1,000 yards, I need to dial 29.7 MOA. And so there is some significant difference. So essentially what we have to do is apply our correction factor. Now some applied ballistics programs, you can input a correction factor and it will give you, when you hit input of 1,000 yards, it's going to spit out this correction factor MOA yardage. But that's why it's important, is because if you've got a scope that's not right on the money, like the Sig is, then you need to make that correction factor. You're going to have a miss, especially at 1,000 yards or beyond. I mean, that could be several inches, obviously. But the other thing that's important is that we notice that the scope is tracking up the line. Okay, this group is pretty much right on center on both the bottom and the top. That tells us that our crosshairs are vertically aligned to the bubble, the scope level. And that everything is level to one another. The scope level is level to the reticle, and that's what's most important. Same thing here. The Sig Tango, my group is just a little bit on the left side of this line right here. And what do we see at the top? Same thing. Our group is just to the left side of the line. A little bit of vertical dispersion in both of these groups, which kind of surprises me for the 6.5 Grendel, because that load's pretty dialed in. You know, it's not bad. It's about 1.25 inches maybe right there. This one's about 1 inch. Could be just some seating depth stuff that we're dealing with there. So I hope this helps you guys. If you have any questions about it, again, all of these calculations are on Applied Ballistics. Brian's got a great video on how to do it, how to set it up. The purpose of my video is not to do that necessarily. It's to kind of show you how the Burris and the Sig Tango perform. They both track very well. You know, this is less than 3%. It's still very accurate. You know, beyond 1,000 yards, I'll probably take into consideration that correction factor. The Sig, we don't need to. It's going to be right on the money. So hopefully you guys get some good information from this. Hopefully it helps you set up your guns and your scopes as well to make you succeed at long range shooting. If you have any questions, post them in the comments and I'll be happy to reply. Thanks for watching.